All right, welcome to lesson 2.2, which is going to be all about direct variation. So by the end of this lesson, I'm hoping that you'll know about direct variation in different sort of worlds, like what does a direct variation equation look like, what does a direct variation graph looks like, and what does it look like as a table. One other thing to focus on throughout this lesson is there will be some vocab and specifically the vocab word constant of variation, which will come up when we do equation. Should be a note sheet to follow along with, so here we go. We're going to start with what does it look like in equation world, right? An equation, forget that just means it has equal sign, right? So filling in a little bit of this information. You've learned about linear equations before. They are some examples would be y equals like 2x plus 6. So you have like the slope, this number in front of x is the slope, and then the other number, 6 is where it crosses on the y-axis. So we could maybe do one more example of that, like a slope of, let's say, 1/2 x minus 2. Okay, those are big example of linear equations. So one way to think of a direct variation equation is it's inside the world of linear, but it's simpler because it doesn't have this y-intercept. So as an example, it'll have, like, say, just a slope. So like y equals 3x, that would be a direct variation equation. Let me go on another example, y equals 1/2 x. Okay, and I think it'll make more sense as we start to do like in the different worlds, because it'll have like some certain properties when they have just a slope and not a y-intercept. And it'll show up a little more maybe in a table. Just if you want to kind of keep track of all this bigger picture of this, linear to the first power. So if you want to just jot down a couple nonlinear ones, you could try and come up with some of your own examples quick, actually, if you want to pause the video. All right, but nonlinear just they have exponents besides 1, so like nx cubed plus 7 or something. And then you can also have what's called like exponential, where the exponent becomes a variable. And that would also be not a line, a nonlinear situation. Okay, so I thought would be kind of helpful would just be to practice this. So here's a bunch of examples of x and y and equations, and I want to know which one of these are direct variation based on this idea that what it really is just a y equals some constant number times x. So this actually, these three of this 1/2, those are what's going to be called the constant of variation, right? So any of these, I'm going to have you sort them quick and pause the video, and then I'll go through the answer with you. All right, so here we go. So probably the best example of a direct variation is the one that's highlighted there. It's gonna mess that up. See if I can get my pointer here. Actually, it's just y equals 7x, so it's just a constant times x. All right, this blue one here, that'd be another good example. This brown one actually is not because of this one, right? So it can't have a y-intercept. These like have y-intercepts of 0. So this one would be a linear but not a direct variation. Same thing with the purple one. All right. This green one here is a little goofy, but really it's like y equals 1/2 x. So that actually is over in the example, so where the slope is 1/2. And then this one's a little goofy, but if you multiply both sides by x, you'd get an equation that looks like this. You get y equals 1.5 times x. So that actually is going to end up being a direct variation. All right, so we're dragging this guy over with the direct variations. The last one here is a pretty tricky one. Again, I would encourage you to solve it for y, and we'll see that it actually ends up being y equals 3 divided by x, and so that's not going to be a direct variation because we have x on the bottom there, so that one is going to be goofy. It's not even linear. If you graph it, you get some crazy looking things. So that is not an example of direct variation. Okay, so more along lines of what you'll see in homework. So this is saying determine whether y varies directly with x or not, but that's basically saying like is it a direct variation. So when it talks about that part, it's just basically saying is y equal to some constant amount k times x. Don't ask me why they use k for constant instead of c. That's always been weird to me, but they're going to call it k for constant of variation. And so it's going to say, okay, if it is, what is this k value? Right? So on letter A here, I would again encourage us to get y alone, right? Which would involve dividing by 5. So we get y equals 9/5 times x. Okay, and so that would fit this picture where it's just some constant times x. So that one would be, yes, it's direct variation, and then our constant of variation called k is 9/5. Sorry about the poor handwriting. Okay. All right, so same thing for B. I would always get y alone. So if you wanted to take a second and think, how would you get y alone in this equation? Okay, and hopefully you came to the idea that if you divide by 3, you get y equals 2x plus 1, right? And then we'll see that that's not a direct variation because of this. The plus 1 part makes it so there's a y-intercept, not a direct variation. All right, last example. Same thing, solve it for y. So hopefully this is kind of some algebra 1 stuff here. If you minus 5x from both sides, you'll get this, 0 minus 5x. Divide by 3 to get rid of the times 3. So you end up with y equals negative 5/3 x. And again, that's going to come under yes, because it's just some constant amount times x, right? And so if we want to finish the directions here, it says list the constant of variation. So that's going to be negative 5/3. All right, up next is to determine in a table, how can you tell if something is a direct variation or not? And the idea is that it'll be a proportional relationship, right? So what I mean by that is, in this case, if you look at x here, that's tripled, and so the same tripling effect happens for y, right? Similarly, if you look at from 1 to 4, that's like 4 times as much, and that's the same thing happens over here. Okay, so this first example is, yes, that's an example of a direct variation. All right, and as far as the equation goes, we know that it's going to be like y equals some number times x. Okay, and so you can more or less do this sort of mentally. Like you can say, okay, I got to multiply x by something to get y. And it's kind of easy to see that you just take it times 2. If you want an official little formula, this little thing can be used. This just basically says the constant will be, if it's a direct variation, the constant will be just dividing any yx pair. So we could divide 8 by 4 to get 2 or 6 by 3 to get 2. That's another way to figure out k, is to use that little formula. But you can also kind of do it mentally. All right, looking at this next table, this one's not a direct variation. It does kind of like double here from 1 to 2, and then it doubles on this side. So far we're good. But if you look at the next pair of points, I want to triple 3, and then if I triple 4, I don't get 11. So this one ends up being no, that's not a direct variation. Okay, and then looking over here at our very last example, it is going to be yes. So again, I think this is like gallons of gas and how much it costs. So if I double how many gallons I buy, the cost doubles. Similarly, if I triple it, then this is tripled also. Okay, so to figure out then the actual equation on this one, the idea is you can kind of just look at it. It would maybe be what I would recommend doing, but we just know that the cost is going to be some amount times the gallons, like some constant amount here. And if you look at the first example, you can see it's kind of like 1 gallon is 225, and so that's pretty much it. Our cost is 225 times the gallons. And again, if you weren't sure, you could use the equation. If you divided a pair, like take that last pair, take 675 divided by 3 gallons, you'll see that it's 225 per gallon, and that's your K, called your constant of variation. Okay, so next up I want to talk about, like, what does it look like as a graph. So I'm going to go back for a moment and just kind of review what we had about what it looks like as an equation. So direct variations are linear ones where the y-intercept is sort of 0. Okay, so in a second we'll fill in this slide on your notes there with some examples and non-examples, but I just thought maybe let's just graph a couple. So if you remember how to do this, pause the video and see if you remember how to graph, right? I guess there's technically a table of points here, but like, you remember how to graph this even if you didn't have a table. All right, so hopefully you've tried it, but if you don't remember, how this works is you just graph a linear one as a straight line, and this has all these direct variations have a y-intercept of 0, and then you just use the slope. So in this case, it's 3 to 4, and that's sort of the rise to the run. So in this case, we're going to go up 3 and over 4 and make another point. If you go 3 and 4 a second time, you get another point, and then if you just connect those points, you get a graph of the line. Okay, so you can graph a direct variation pretty easily because it's just a slope and a y-intercept of 0. Okay, so on the second one again, I can just start at 0, right? All these direct variations will start there, and then this slope is now, because it's negative, we're going to go down to, and then to the right one. So this is a downward sloping line because of the negative slope, and then you just connect those dots, and you have your line. Okay, so just to generalize this, if you want to try and do this, an example, they go through 0, 0, and then they're linear. So what do you think that would look like? All right, so maybe add a couple examples here. Okay, so now that you've tried it on your own, you can just draw a straight line. Sorry, that's not very straight. Or here's another wow, that's terrible. I have a hard time drawing with this pad, but they're just straight lines that go through 0, 0. All right. Non-examples would just be curves, right? So if you want to draw like an exponential curve, kind of goes up slowly at first and then rockets up. And then an x squared actually is this parabola shape, right? And so that would be an example of something that's not a direct variation. You could also draw a line, a linear one that doesn't go through 0, 0, right? It has a y-intercept, say, of -2 or something. That would also be an example of something that's not a direct variation. Okay, so my big thing is that you understand what direct variations are in these different worlds, right? And hopefully you've got a grasp of that. Unfortunately, homework has some weird questions. And so I'm going to walk you through at least one of these. If you get the first one, you probably don't need to watch the video for the second one. But I thought I'd give this to you before you kind of dive too far into the homework. So I'm just going to break this down, right? Because there's a lot going on here. So it says y varies directly with x. Okay, so what do you think that means? Right, based on what we know. Okay, so just that part alone tells us that it's going to look like this. Our equation for y and x is going to be, y is going to be equal to some constant amount k times x. All right, and usually k is like a number. So if we look back again, right, at some examples, k is always some like fixed value or something like that. All right, so back in our problem, we have to figure out what is that k. Okay, and so that's where this next piece of information comes in. It says when y is 15, x is 3. Okay, so what I can do to figure out what k is and say, okay, well, I have 15 for y. I don't know what k is, but x is 3 when y is 15. So I plug this in and say, oh, okay, what number do I need here? You can kind of see that it's 5, right? Or if you want to like solve this, you can divide it by 3, and then we figure out that the constant is 5. All right, so that gives us our equation. So now we have y equals 5 times x, right? And so that is our direct variation equation. All right, but then it asks, like, this is the part I think it's confusing, because now I throw about 8 bazillion things at you all at once, which kind of frustrates me if I'm honest. But it'll say, what is y when x is 12? So this is kind of like a follow-up question. So sort of like we have one point that they gave us when x was 3, y was 15. All right, and so now they want to know if we have an x of 12, what is y, right? So we can essentially just sort of plug this in and then go from there. So y would be 5 times 12, which would be 60. So you see this hopefully on your note sheet. I'm going to make another video on this because I ran out of time here. This is a summary, and so if you're not sure of the answer of this, watch that summary video. If you are sure of the answer, you feel like you got a handle of this, you can start this homework. Remember, check your answers out on the class website as you go. All right, good luck.